and welcome back to Altair Insights podcast. Today we have another great episode that will be coming up. And this individual here has a lot of experience that he is, again, willing to share, and that's going to be an awesome episode. So make sure to tune in and listen to it thoroughly. So we're joined today by Mr. Andreson, right? Grant Andreson, who is co-founder of Paragon Space Development Corporation. And he co-founded it in 1993. Now he is the president, CEO, and he has held diverse positions at Paragon, including chief engineer, VP of engineering, treasurer, secretary, CFO. So everything basically that's a leadership position that there is pretty much. Also director of manufacturing as well, right? So pleasure to have you on, Grant, again. I see you have a very diverse background. You come from a technical background, but then obviously you excel at the business side of things. And I'll be very happy to discuss also today the philosophy behind the business as well and space entrepreneurship. But also I'm eager to dive into the Paragon services as well regarding the life support and the adaptation to the space environment, different components, and all of this really necessary things that you do. So pleasure to have you on once again, Brett.
Great to be here, man. Go ahead.
Good, wonderful. So first off, I think as a starting point, maybe we can just maybe you could just give us a backstory of how you got into the space industry in the first place and how everything led up to the creation of Paragon.
Okay, sure. And I don't mean to I won't do this long, but I do want to start all the way back to my childhood. This is actually I'm the son of an American diplomat, so I grew up actually overseas, 13 my first 18 years. I lived in Austria and Belgium and Norway. My last 3 years of high school in 3 different countries, let alone 3 different high schools. And then I went off to college, but I'll admit that my love of airplanes and aerospace happened during my first trip across the ocean on an airplane. My first 4 trips were on a boat, to give you an idea of how old I am. But when I flew to Belgium the first time in 3rd grade, I was on 747. But I became an airplane nut, that then evolved me into a space nut when the space shuttle was coming up. The space shuttle actually launched 2 days after I found out I was accepted to Stanford University in my senior year of high school. But then I really actually chose Stanford for its graduate degree in aeronautics and astronautics, but I had a fairly fairy tale experience there because I also found a job off campus working for an aviation consulting firm, which allowed me to, for one thing, become their controller for things because I understood computers. This is when this brand new thing called the IBM PC hit desks back in the early 80s. But it gave me a plethora of good experiences, as well as learning the finance side of everything. We had a very small part in the start of 2 different airlines, and that was all before I graduated. And then one of the other things that was one of the other things was that the guy who ran the aviation consulting firm was also the professor of entrepreneurial management at the Stanford School of Business. And so sometimes he would come in and say, "Hey, I'm having Steve Jobs talking to class today. How would you like to go lunch with him?" So I got a very interesting experience and learned a few things from that. One is that talking with these luminaries like Steve Jobs, Ray Noyce, Herb Kelleher, started Southwest Airlines, Ray Noyce, with Intel. I realized there were special characters, but also that they weren't superhumans, I guess. But I graduated from Stanford and went to work for Lockheed in Sunnyvale, California. Did some defense programs and then moved on to the space station. And I realized that what I really liked about engineering, I was a design engineer at the beginning of my career, was designing around humans and designing for humans. Anybody can build a spacecraft. It's like a robot, but in a really cool place. But when you have to build a human-capable spacecraft, it really takes a lot of differences. Human engineering, design engineering, human factors stuff. And then about 10 years, well, actually about 8 years into my career with Lockheed, I went to the International Space University, and I came back from that convinced that the world of space was changing some. Tried to get Lockheed to maybe go along and do a few things differently, but pretty soon realized that it was probably going to take starting my own company with some friends of mine, with all of us on input on what we wanted to do. And so I started Paragon with the biologists and chemists and some other aerospace people, knowing that we had to be this interface between the techie aerospace structured world and the much more free, so to speak, chemistry and biology world. What we joked about is we were the people who were the translators with the people with detectors and
The mediators, yeah, exactly.
Versus the people in Birkenstocks and lab coats that were the biologists who kind of stuff. So, but we started out Paragon with the idea of space station coming along. We're gonna, in order to do biological experiments and stuff, you need to have an understanding of both. And then we've evolved, and our vision has been since the beginning really to be doing human spaceflight, life support, and thermal control and experiment.
I see. And for the audience, keep in mind, this is happening in early 90s. So the space industry, the private side of it is just pretty much non-existent at that point, right? So this is actually, I think, one of the first like private companies that there are, right? And also what I caught in your story, Grant, again, starting the love of space from the childhood, right? I think that's a common thing for all like individuals that are in space and space business, especially, right? Because I have not met so far an individual, because I had many conversations on podcasts, and besides that did not have some story that dated back to their childhood that connected them to space, right? Like myself, for example, I had this old like Soviet like dusty telescope on my balcony, and I used to observe the moon with my grandfather, right? So that's where it started for me, right? And obviously hearing now that you flew with the 747 and that kind of started your passion towards aerospace and space also, that's just awesome, right? That's amazing.
Well,
amazing. Yeah.
And I'll admit, I even skipped off. Of course, I do remember the Apollo moon landings. I was 6 years old at the time, but I do.
Wow. Yeah. Well, that also plays part, right?
Right.
Yeah.
Definitely.
Yes. Wonderful. Okay, so now moving on forward, right? So, okay, Paragon is now established, right? And now you have to navigate through this. You have to create this value proposition for the sector, right? So how did you approach this? Because your segment is quite unique, right? So it's very needed, but quite unique, and it's also a bit challenging, right? So was there any like innovative, like specific methodologies and technologies that you use to again produce your products, or how did you approach this? Did you go for a traditional way of things, or did you actually try to innovate? Because how much of innovation was happening back then in like manufacturing things and in your segment?
Wow, yeah, that's a loaded question, because really there was three different areas probably of differences. One is I'll have to start with the culture of the company. We started out to do a different type of company. I spent some time in corporate America. Some of my other founders had also, but then some have done some very non-traditional things, like being in the biosphere for 2 years and actually living. Two of the founders lived in the biosphere for 2 years when it was closed in the early 90s. And but I recognize there was a lot of pathologies associated with how big aerospace business worked. Just the structure and how they did things. There were some very good things. I mean, when I worked at Lockheed, Kelly Johnson was retired by then, but I still worked with documents that were signed by Kelly Johnson, the guy who designed the U-2 spy plane, the SR-71 with the skunk works. There was a rich history of very good, innovative engineering works. But the structure of the corporate America at the time, it was still very much the glass ceiling, sort of the old boys network and all that. And I realized that Lockheed wasn't working at its optimum at that time because of those sort of leftover 1950s, 1960s attitudes toward business. So that was one thing. So the innovation in how we structured the company and how we treated employees. The other one was we had recognized that in general, the biologic experiments on the early shuttle years were designed by aerospace engineers, and they did not really optimize the science because sort of the aerospace overrode the biology and chemistry to some degree. So combining that together and doing the very good systems design that's required for them. Like I always say, the environmental control and life support world, we are the best systems engineers in the world because we have to understand everything going on in spacecraft. We touch everybody. We keep the avionics at the right temperature, batteries at the right temperature, people at the right temperature. When we need to know where the radiators are pointing, so you have to understand the total spacecraft. So we had developed very early on this thing we call the rubber spacecraft, where we had a very complex model that if we change this, it would tell you all the other changes that had to go to the spacecraft, how much bigger the batteries get because of the power you use and all that.
Mhm.
And then the third innovation was actually the biological side, because people were scared of biology. Aerospace engineers, they wanted to but they're scared of biology. We developed, Jane Tabor, and then I developed a lot of the mechanics of it, was something called the autonomous biological system, was a biological payload that you could put in space that would support itself and have very little interaction with everything. All you needed was light, really, and to keep it at the right temperature. And so that was actually our first product that actually flew. We started in '93, and our first flight on the shuttle was in '96, and we flew one of these autonomous biological systems up. And I should say, all of this is wrapped around as nobody really just jumps in and says, "Hi, I'm an expert now on. I went to do these classes in school, and now I'm an expert on space life support systems. So buy my product." You have to really earn your respect, if you want to say that, or earn the grudging respect of the people that you work with, and nope, it's a life critical thing. So you just don't want somebody fly by night coming in and doing something. So all during this time, too, the first decade of the company was doing all of those things at once. I guess is the way to put it.
I see. Yeah, and this is typical generally, like even up to today, right? In the space industry, it seems like, you really have to be here for a long time to get this trust from individuals, right? And
or have enough money to hire all the people that have that trust. That's the other
exactly. So when was the first moment, Grant? Obviously, because when you started, right, space companies, they're typically like capital intensive, right? They require capital, and back then, I'm gonna assume that no private investor was like publicly available to invest in the space industry. So how did you approach that, right? So you probably went for the government contract, right? As you mentioned, the shuttle mission. So that's obviously that's one of the things. So yeah, how did that go for you? And when was the moment that you knew, okay, we're gonna do this, like finally, right?
Well, one thing is we didn't go out to the investment world. You said it really didn't exist for space, especially, but also having worked in the startup of some companies beforehand, I had a fairly jaded view of the VC world and the venture capital world, because they do, especially for something that's very innovative and very new, where you're almost inventing the market.
Very scary for investors. Very
Right.
scary. Yeah.
You're going to end up with valuations so low that anybody puts any money in, they're going to get a really big chunk of the company. So we bootstrapped ourselves, and we had some aborted attempts. Some of it was the occasional contracts. We did some very interesting things. We designed a mirror system, a heliostat that would provide more light to grass in what was then called the Bank One Ballpark, now Chase Field in Phoenix, so that they could grow grass. Literally woke up every morning and directed the sunlight to places where there was shadow or they needed more sunlight to make the grass grow. We did some stuff with Eritrea through a company out of Phoenix. We got asked to actually work with Marlon Brando on an environmental project with him. So I got to meet Marlon Brando. I could write a whole book on the little things that happened here, but really that first bunch of years was surviving. Oh, and we also invented a retail product based upon our patents that we sold in the retail world, and that also kept us a little bit in the money, but it was no big.
That helps. Yeah.
Well, it helps, but I will, when I now teach business schools, I say don't get defocused, and that definitely defocused us on what our goal was, because we were kind of chasing after money, and I realized when I was in the back of our factory counting snails at 2 o'clock in the morning that we had gone the wrong direction. And so we said, okay, either we go back to why we started this company, which was the airspace and the life support, or we fold.
Back to the basics, yes.
And we did. In 1997, we shifted again, 1998, and within a year, we had contracts with Lockheed and a bunch of others on developing life support systems for spacecraft again, back to where we really had started, why we had started.
Wonderful, wonderful. Okay, so this sounds all good, but now I want to inquire a bit more about your constant roles, right? That you changed within the company, which is typical for generally like founders to because one day you were when you were starting out, one day you were a like lawyer, one day you were a like salesperson, one day you were a strategy officer, right? So everything together, but obviously with you this happened throughout the period of time, right? So how were these transitions happening for you, and did this mean that you were like finding individuals to substitute you in like specific roles, and then you were kind of taking up another role, or how did this work? So I want to just inquire regarding.
So yeah, I do also talk to business schools about this. What I believe is the advice I give to new CEOs, and I do a mentorship for CEOs. In fact, I specialize in female CEOs because I've always been like when I left Lockheed, trying to promote and help women in the aerospace world. In reality, every business is a set of functions that do a process that produce more value than it costs. Every business in the world is that. And nonprofit, profit, whatever. And those functions, what I recommend people do when they start a company is figure out what your vision is, what you want the company to do, and then write down the functions you need to do that. And you will get to some of the typical ones. You need a financial function, accounting functions. But you might have different ones too, depending on whether it's a retail coffee business or an aerospace company. But in reality, when you start a small company, it's not that you don't have those functions, it's that you're doing multiple ones. So you have to do a lot of them at a time. And then the idea is that if you've thought about this well, and even written them down, we have something called functional contracts that say, here's what the success criteria for this function is, here's the responsibilities and the authority and how you do this, that when you grow, all you're doing is, as the entrepreneur, handing off the functions that you need other people to do because it's getting too big for you to do all the functions. So if you do that up front, you have a better chance of scaling your system quickly because you have that idea that, okay, I need this function, but I don't have time to do it. I need to hire somebody that knows how to do this function in a direction. But in the case of me moving around, part of it was that growth. And we started off for many years being intellectual in that our products were paper, our products were studies, our analysis of preliminary designs. But that as we got into manufacturing, we needed to build our manufacturing side. So that was a new function we needed. And very often I was called upon to do those functions because of my history, my background, and my understanding of the subject matter. Usually then building it up to a point. Sometimes starting it out, bringing in somebody that started out and finding out that they weren't really working out, so I'd step in and do a bit and then re-hand it off, so to speak. And then part of it is just because I won't say I'm ADHD, but I have I have an interest in a lot of things, and so I tend to read a lot, listen to people a lot, and stuff. And so
that certainly helps. Yes.
Yeah, from that I'm a polyglot. In fact, you can say that one of the parts about attracting me to life support is that you have to know so much about so many different things. You have to know mechanical engineering, you have to know electrical engineering, you have to know biology, you have to know chemistry, you have to know control theory, all these different things. And so I think environmental control and life support is one of the ultimate systems engineering, multifaceted engineering issues we have. There is no, by now, environmental control and life support degree you can get out of college. The closest we have to it is like UC Boulder, Leonard, Dave Klaus and others have developed a coursework that does a lot of what we want, so we hire a lot of people from there. But there is no one degree. You really have to get to know it all. So I find it, having done so many things, it was an opportunity to learn, which is one thing. It was an opportunity to bring some of the knowledge I had. And there is, I will say, a little bit of benefit to walking into something and being a little naive because you tend to think out of the box. For your people, I recommend they read a book called Range by David Epstein, which talks about how true innovation happens with people. It's either when different people in the room that are totally different, have different backgrounds, or a person that has very varied interests tend to be the best innovators because they can bring in things from left field and other industries and stuff, and they're not really rigid on what they know just in this area. So anyway, that's
Yeah, that sounds very close to the message that's also described in Blue Ocean Strategy, in that book as well. I don't know if you.
I have not read it.
Yeah, that's very similar messaging, actually. Innovating really, rather than making those like small incremental like improvements, but really innovating. And all the companies that are now, competing on cost and like efficiency and their quality of their products and services, you really need to create like new markets, right? You have to really create the new service that will just disregard the competition, right? So that's a very similar messaging as well. And yeah, for sure, that's a great book. I might check it out as well myself. So that's interesting.
Yeah, I wrote it down.
Yes, good. I can get back to it later once the episode is out, and I'm sure the audience will take the notes as well, and they will check it out as well once they get a chance. Obviously, now we discussed a lot of things, and you also touched briefly upon how complex this whole system is, right? Because you really have to understand all the different segments of the environmental control and thermal control and space missions and ensuring the safety and functionality of the spacecraft. So all of that. So if there was, let's say, several specific things that you would like emphasize that can go wrong, right, in this process, so what would those be, Brent?
Wow.
That could have like really like dire consequences on, okay, you have to start from scratch, right? Or to that degree. Yeah.
Well, the one thing and the big change I've seen in the space world is sort of the Elon Musk, build and failed fast, build it and break it. Definitely as we stepped in and when I was learning in the space world, the human spaceflight world, one thing I didn't mention is my first real long-term human spaceflight job at Lockheed was to be the chief designer for the solar arrays for space stations. So the big blue and gold things you see that are now being replaced, like this morning, last night they replaced, or they put a new solar array in, because the ones I designed are old and well past the life and older technology. But the thing that can go wrong, I think, mostly is that the true time to innovate on a design and innovate on something is early in a program. And true innovation does not happen unless you have stressors of the environment. In other words, if you're trying to break into an environment, or if your budget's restricted, or your schedule's restricted, or your technology doesn't quite get up to stuff, that's when true innovation happens, because you're forced to innovate. Nothing could be worse for a company than you just sitting back and rolling in the money, and you're not.
Well, how long they're going to roll the money, right? Not for long if they keep it up like that. So
now there's another great book called The Innovator's Dilemma that talks about the memory industry in the computer world, and that the leaders in tape memory were not the leaders in disk memory, which were then not the leaders in solid state memory, because they didn't look ahead to see what might replace their own function. Again, it's a function. Well, it's a function. Store data. And they didn't look what's the next technology store data. They just said, hey, we're building 5 1/4 discs and we're making oodles of money. And then somebody came along with a 3.5-inch disc, and your listeners may be too young to know what those were. But you've got to keep your eye on the ball, look ahead where things are going to go. The one thing I think very unique about the space industry too is you have to be a long-term thinker. One of the reasons we've never gone public is because I couldn't survive in a quarterly report environment where I have to show results quarter to quarter, because sometimes I have to take pretty big hits in my profits and my stuff in order to put the money into something that I know is coming down 5 years from now. Our biggest money-making products right now, we started developing over a decade ago. So knowing that there's going to be demand for these, and where it's going to be, takes a deep knowledge in the industry, a deep understanding of where things are going. I have a constant refrain I've made is that people forget about high support. Very often, if you want to make NASA get a little mad at you, say, in reality, the human spaceflight part of NASA is a biology enterprise with a little bit of rocket technology thrown in.
Mhm.
And it really is. Everything's designed around the human. The Saturn V was limited its thrust. The shuttle pulled back on its thrust. It was to really to keep the thrust, the G's on humans below a certain amount. Yes, they had to reduce dynamic pressure, but the whole enterprise is long term and needs to have that long term view. I didn't start Paragon thinking I was going to start a company, become a unicorn, and then cash out in 5 years. I started this as and I know my business partners are on the same thing. It's a long term endeavor to
You have to really scale it, and yes,
well, to scale it and also
and to stay hands-on, right?
yeah, if you told somebody 30 years ago that there was going to be multiple companies building space stations and stuff, that was a few sci-fi novels you had.
Yeah, exactly.
It wasn't, nobody was going to give you money to go develop it.
Mhm.
And I'll admit it went slow for the first bit, and then the Entrepreneurship program happened. We met Elon Musk, and he got mad at the space rocket industry, started the SpaceX, and then he needed somebody who knew how to do life support systems for the Dragon, so we got involved for that. We the whole architecture of the Dragon vehicle is life support, as well as the Boeing CTS-100's life support architecture is Paragon.
Mhm. Yeah, exactly. And very important thing that you mentioned also for that the top selling products that you have, top revenue generating products that you have right now are the ones that you developed a decade ago, right? That you started developing a decade ago. That's also what Jeff Bezos often mentions, right? So you don't want to jump on an existing wave. You want to position yourself in a way that when the wave comes, you're going to be on top, right? So that's what he says. So that's also consistent with that. But also, as we're talking about like starting the company itself, right? And you as you're mentioning that there was no currently like this was like sci-fi that this would be needed like so far into the future, right? And now, as we were also talking about the books and everything, so this reminded me one more book which is by Altair. It's called Positioning, right? As we also mentioned positioning just now. So how did you position yourself? Because in the book, Paul Rice mentions that 4 things that typically companies do is 4 Ps, as they call it, right? So 4 Ps meaning product, price, place, and promotion, right? Which is typical for each company. But also, he says before the 4 Ps comes an R, right? Which is a research. So what did you base your research and your vision and estimation on back then? That now, obviously, as it seems, you were right? When we're looking from the future's perspective.
Well, I mean, definitely some of my business partners brought a lot of the thought for closed systems and stuff, having been involved with the Biosphere 2 project. I think in my case, the vision, the research that I did was I was a student of Apollo and shuttle and stuff. So maybe you had your fans that read everything they could about the Apollo adventure and the shuttle. I actually was diving into technical manuals, finding them online and trying to figure out how they work. I mean, I have an extensive library, probably one of the better ones outside of NASA, of all of the life support subsystems for Apollo and for the shuttle. And so part of it was that type of research, looking at who was building stuff now, who did NASA go to, but it was mainly NASA for different things. And that's one thing that was daunting when we started the company. The 2 biggest life support companies in the United States were what was then Hamilton Standard, which became Hamilton Suntran, which became Collins, now part of Raytheon Technologies, and the other one was Honeywell, which was Honeywell actually was a combined with Allied Garrett, I think, and they actually the ones who built the Apollo stuff. So knowing who did that beforehand was all important. But I would say that the data was out there, and I learned this also with Elon Musk. Is fantastic at finding out who knows the best about any one thing, and then hiring that person long enough to learn everything they know. And I was not as, we were not as deliberate as that, but I remember Hank Rotter was integral and oversaw the development of the life support system on shuttle. And I was down at NASA and I walked into his office totally unannounced. And I said, Hank, tell me every mistake you made on the life support system for the shop. And he said, why? And I said, well, because I'm designing them. And if I make a mistake, I don't want to be called the Hank Broder mistake that was made again. I wanted to be known as the Grant Anderson mistake because it was unique. And I think he liked that. And so he literally cleared his calendar and sat down with me for 3-4 hours and just talked about all of the lessons learned that he had from having developed the shuttle one, what the problems were. And then, being humble enough to ask people about that and not be worried about what they speak. And why did you do that? Well, and sometimes you get brain fog and you realize, well, as a trained engineer, I should have known that would have been a problem. But yeah, you don't at the time. And there's many times when trained engineers have gone down a path and realized that if they would have thought about it better 2 years before and done about 5 minutes of calculations, they wouldn't have done it.
Yeah, very, very valuable. When you don't know, ask somebody who knows, right? So that's obviously very, very important. Always.
Or read the books. A lot of it's out there in books and stuff.
Yeah, in books as well. And since we're talking about books, right, Grant? So a lot of individuals, especially that are starting out in the space business, right, young entrepreneurs, they have this maybe like false vision that, okay, they have to only read like space books, right? So, which in reality, as you described, like business is the same in all the industries, right? So it all comes down at the end about business and about yourself, right? The way you think yourself and the way you operate in, just generally about yourself, right? So mindset. So what obviously you already recommended a few books to individuals, but typically, so all the reading that you're doing, right? So a lot of entrepreneurs, they just put their head down, they just work, they don't read, they forget about self-development, everything. So how was this for you, and what would you recommend to those entrepreneurs? So how do they approach like self-growth, and how often should they read, and like what is the milestone they should, like a year, like how many books would you recommend them to read, and so forth?
Yeah, I think I read somewhere between 10 and 20 books a year.
Yeah.
However, read is no longer the word for it. I listen to them. I have a podcast in my ears or a book in my ears every single day. I walk my dogs for 45 minutes every morning.
Exactly.
A mile or so. And what I'm usually doing, if I'm not talking to somebody on the East Coast, because I'm in Arizona, which is on Mountain Standard Time. So right now I'm 3 hours behind the East Coast. So I either use that time with the dogs to talk to people on the East Coast that are up in the morning, or listen to a podcast, listen to a
training material. Yeah, always feeding the brain, right?
There is no excuse now not to keep up with things just by asking around what's good books to read. That's why I wrote down the ones. I'll probably go down and download these, and I'll have them read in the next month or so.
Yep, absolutely.
So
and another funny research, actually, as well, not funny, it's funny, but it's also very important that there was a research done that calculated if individuals, when they're driving a car to work and back, and to the store and back, and obviously, if they, instead of listening to the music and radio, if they instead listen to training material, in a year, they would be consuming the same amount of information as they would in a 40-year degree course, right, at the university. So that itself speaks volumes, right? So utilize that as a business owner is just a crime against business, right?
So, right. And then the other thing I found is there are multiple articles about running a business, and there's this little spike of every so often another big star in the business book world rises. Drucker back in the Peter Drucker, the Peter Principle and stuff, and whoever wrote Good to Great or whatever. There's these spikes.
Yep.
You should read them, probably just see what other people are thinking. If anything else, to know what your competition is thinking.
Yep.
What I've found over 30 years of my own company and 40 years of the business is that all of them had a certain amount of truth, and then a lot of it was also was inferior. Essentially, it was maybe true for the time, but 5 years later, it wasn't true anymore. So you've got to watch out how much you absorb, and it's sort of like if you map out a route, then don't look to find out that, hey, by the way, the route changed and the highway's closed, and you got to take a different route.
Exactly. And also, like, reading and consuming information is one thing, but how many of it actually do you decrypt and really analyze, right? That's also another thing, because I know a lot of people that read like a lot of books about business, but they don't have a business, right? And I know a lot of individuals that just read the books. And for example, if I read, because I read several books like several times, like twice or something like that, right? The same exact book that I'm discussing. And the information that I extracted from it 3 years ago is completely different to what I extracted from it, let's say a few months ago, right? So that there's a big difference of that. And how you perceive that, that's another thing. And you have to read between the lines and really like go deep on it, but also thinking, okay, how can I apply this in the situations that I'm doing right now in my business, right? So, or how can I prepare for a near future situation using this? So that's it.
Yeah, and keeping your eyes open. There's more than one thing when I'm lecturing business schools and stuff where I say this is how Paragon does something, and a professor will come up to me and say, I've never seen that. Why? The whole what I mentioned, the functional contracts. When I show them to people, they go, that's great. I've never seen that before. Well, Paragon has developed it over the time of looking at what we needed in order to get something done. And in fact, one of the interesting things of new people coming into Paragon is almost having to deprogram them from where they came from, because they have taken all that and said, this is the way to do it. And they come into Paragon and we do it differently. And I've had people say, well, I don't want to do this, this, and this. And we said, well, we developed this over 20 years and it works. Well, it's not how I did in my own company. Well, open up your mind a little bit. There's a reason why we do business. I can say it now, this sounded conceited when you're 5 or 10 years into it, but once you get to be 30 years old, you're doing something right. As a business.
This was also another great book that you mentioned, Good to Great, right? Why some companies become the best, and obviously that's also what's being discussed there in that book also, about some of the biggest companies and how they managed to keep for more than 15 years in terms of their success and outgrow the full market, right?
Yeah, well, and it's interesting having seen like the Jack Welch era in GE, and he was seen as the guru of everything, but now he's no longer there. They've really fallen a bit on hard times, and his philosophy of essentially firing the lower 20% every year. That's not how I want to run a company. One, and B, you've got to watch out for the big hairy ass goals, pardon me if I'm allowed to say that on a podcast. You got to watch out for those, because you got to look to see how they work behavior. If you look at the Enrons of the world, how they got in trouble is they focused. Enron was balance sheet. Balance sheet's got to look good. So what happened is they innovated a whole bunch of different ways to keep things off the balance sheet and essentially work them into bankruptcy and fraud even. And with GE, the firing the last 20% means that everybody's competing against each other. So you don't really have a cooperative, collaborative family atmosphere where everybody's looking out for everybody. And you can make a lot more progress as a group of people all looking out for each other and playing off of each other and catching something when somebody falls off of somebody's plate, knowing that they'll do the same for you. And everybody's life goes through a different thing. You go through kids with school problems and divorces and everything else. All that's going to happen in the background. And if you have a collaborative environment at work, it's a support network. And that's how I saw business, as opposed to the, one of the things that bugged me about corporate world was the review process and the merit raise process. It was, we're only going to allow for a 3% merit raise this year on average. So that meant to me as a manager at Lockheed, meant that if I had 40 people or so working for me, I had to get an average of 3%. So that means if I had somebody that was really good and I gave them 6%, I had to give somebody else 0%.
Yeah.
And that's, you can call that sort of the Jack Welch.
Yeah, I think that just puts like yourself in some sort of a corporate, very much corporate bonds, right? I personally don't like those things. Like anything that relates to big corporate like this systems that really slow you down along the progress. Because what we're doing here, in our company and typically how we approach business, we want to stay like versatile, right? We want to have the startup mentality all the way through, right? So until they obviously exit, which whatever that's going to be, right? Because as you said, we're not building this to sell just like you were, right? We're building this to really grow it and stay hands-on, right? So that's
knowing that if you're really successful, somebody's going to be coming along and wanting to buy you, but it's not something you seek out. But Well, back to what I was saying, the problem with this whole process of having a pool and that is that you incentivize people to not work together and you gain nothing by making Joe or Sally next to you look good because it's going to actually detract from your financial performance, your financial rewards. And so what Paragon's done is we said, okay, everybody has a certain level that they can get. And we have to do that for financial reasons, but it's your own individual performance that determines what that is, not the company, not the if you're not average with everybody, it's easy to do, it's easy to decouple. But it's also anyway, that's one of the things, and that's another thing where we've told people how we do what we call our RER process. We use expectations and results. It's our review process we do twice a year. And we explain that to business schools and they say, wow, that seems complicated. That's the most important thing to do, because if you're good at that and setting up your people for success, the company will be successful. It's just it's a given by that point.
Very, very important. Yeah, you don't have to be a king, but you have to be a king maker, right? As they say. So
yeah, that's a good thing.
Yeah, absolutely. So obviously we had some great discussion right now about the business side and personal development and all of that, right? As we name dropped some great books, and I'm sure the audience will grab onto them like one by one and have a read at them as well. But if we come back now to one of the things that we mentioned earlier, Grant, which is like Elon Musk's mentality in terms of like build and fail, build, fail, like change, improve, right? So in his case, okay, he has to develop the rocket, he has to launch it, he has to see how it works, then get the data, then fix that and launch again, right? And see how it works. So in your case, what is the way to actually test these components and these things that this products that you're developing before you actually launch them to space, right? So how do you test them on the ground on Earth?
Yeah, well, we actually have a patent on one of our test facilities, so it is a unique thing for life support. But we have facilities that we can mimic the inside of any cabin of any spacecraft, and so that means at the right pressure, which is always going to be less than 14.7 or whatever. So we can mimic the pressure, and then we can put pumps and vacuum systems on the outside so that we can simulate leaks. We can also put a metabolic simulator inside that will simulate the breathing and sweat and moisture from anywhere from 1 to 7 people. And you can stick that in the chamber. And you need that for the variability, because one of our biggest problems is that astronauts don't just sit there and breathe exactly the same all the time. They exercise, they sleep, and because you're doing the environmental control system, if you set it to take out as much water as it needs when they're heavily sweating and exercising, they go to sleep, you're going to dry them out, and they're going to wake up with a really dry throat and also bleeding, nosebleeds and stuff. So we need a chamber that can do all that. Really, you need a fake human, what we call a metabolic simulator. You need to be able to do that. The standard get through the launch type stuff, vibration, shock, that type of stuff you need to be able to do. The thermal side, we do radiators, so those are actually things that radiate the heat to space. We actually do not, believe it or not, have a thermal vacuum chamber. We don't test our radiators in-house because it's just cheaper for us. We have a great relationship with National Testing Systems up in Phoenix. They can run it. But the key is, even in the case of we're not having to blow up a rocket, to find out if something goes wrong. We can test a failure. We do that a fair amount. Just getting it in these chambers and testing it in the realistic environment of loads and things, and simulating failures. So simulating a leak in the spacecraft. Does your pressure control system let the spacecraft drop from 14.7 or 10.2 down to 8 and then hold it for a certain amount of time until you can fix the leak or until you can return home? Those types of failure scenarios are all necessary to sort of make sure that you designed in the box of the performance criteria. I got to admit, that's one thing about looking at the Apollo and the Skylab was really the first longer term one. boy, the engineers that worked on that were just impressed as I get out. It's a really interesting detail. The CO2 control system, so was a swing bed, so it would switch from a bed one absorbing to another, and while you were absorbing the CO2 on one bed, the other one was off gassing it into space. The one interesting cool thing about the Skylab one is they made it a pneumatic system run by the oxygen system. Well, the amount of CO2 you produce is proportional to the amount of O2 you produce, you consume. So by making the valve, the system that changed the valves an oxygen and then an oxygen pressure system, every time you vented it out to move the valve, you added oxygen to the air at the same proportion you were letting the CO2 out. I mean, it was a self-regulating system. It was beautiful, elegant design. You do find in this business, the simplest designs are the best. The saying is, it's really easy to make something complicated. What's really hard is to make something simple.
That works. Yeah, exactly.
Yeah. A complicated thing to fail also has more failure modes and stuff too. So. Anyway, so yeah, we have to have a fair amount of extensive testing. It's one of the things. It's one of our capital structure issues. Is we have to have so many. We have to be able to handle noxious chemicals, handle fluids, and then some esoteric materials that have very specific temperatures that you have to store them at, and all that type of stuff. A lot of materials that have a shelf life go into a life support system too. So it's capital intensive to some degree for a life support system, almost more capital intensive than anything else.
Okay, so my next question, Grant, is as we talking now, as we were talking before about the wave and catching the wave and preparing, your services for the wave that's going to come, because the demand is going to be there in the future. So I think we still have not gotten to that point where the demand is at its maximum, as now we have some of those projects like lunar projects, and we have Mars mission is just over the horizon, right? So how do you see Paragon being part of those projects?
We are part of those projects, and that's all I can say. But yeah, I mean, when I do the elevator speech, I meet somebody and they say, "What do you do? And what's your purpose? What's your vision?" The shorthand of our vision is that when you or your kids or your grandkids fly in space, they'll look up and there's going to be a plaque that says "Your life support by Paragon," and that's all they need to know, that they're in great hands as far as the life support system is concerned. So we have the ambition of being on every single spacecraft in one way or another, at least one of our components, if not the whole system. The other thing is I have outside my door a picture of an artist concept of what the Milky Way galaxy looks like. And I've got a sign underneath that says, "This is our business territory." Life support will be needed as long as humans go to space. And, until we can download our brain into some, quantum computer that then goes off into space, we're going to need a full life support system. And by the way, the quantum computer still will need a life support system, thermal and everything else.
Yeah.
So essentially, I'm in a perpetual business. The way to think of it is I know there's 7 major categories of businesses in the world. One's information, one is shelter, one is food, one is transportation, and I always forget the other 2, but there's generally a lot of business or a lot of books that talk about the big picture. Is the issue with life support is that there isn't, although you can call it kind of part of shelter, the life support incorporates some of the food portions, but the other one is the oxygen. You did not leave your house today wondering if you had enough oxygen to breathe throughout the day. It's just provided to you. It's there. It's wherever we go. We live in a 21% oxygen environment in the world. You don't have that on a spacecraft. So you're going to have to provide that no matter if humans are going anywhere. This is why I call human spaceflight a biological system with a little bit of rocket technology. And you need that life support capability. So we don't see a peak. We have a peak right now because there's 5 different suborbital, LEO destinations being designed and in preliminary design. There's 2 different human landers for the moon. There's multiple people, a lot of them I can't name, that are designing habitats for the moon. There, of course, is now the Moon to Mars office at NASA that's thinking about how to get to the moon. There's no lack of work on it, that's for sure. But ultimately, it will get a little bit like it is on Earth, that when you go from Earth surface to Leo and then off to a transport that takes you to the moon, and then you land on the moon, you're going to be going from life support system, life support system, life support system. And the more that we do that market to that life support system won't die. We need it. It will get as big as humans get expanding into the universe and into the solar system, and hopefully eventually in the universe. It's going to be there. It's a perpetual business. The question is will Paragon still be there doing what we do?
Yeah. So talking about this ambitious goal that you mentioned on being on every spacecraft out there, right? So obviously that's awesome. And my question is, how much of the standardization is going like in between like those spacecrafts and the life support systems that they need, right? So how much of a standardization is up there so that the compatibility is existing, or do you actually have to develop a brand new system for each of those spacecrafts, right? So how does that work?
No, Paragon has what we call the common ecosystem. So there are certain elements of the system that are going to be always the same or very close to the same. And the idea is to make it modular, but adaptable enough to the specific mission. So, I won't say, but we have designs for 2 different life support systems for 2 different numbers of people. In other words, one will support X number of people, one will support Y. And we see as the space station grows, you'll be combining the X's and Y's, and we actually chose the number of people to kind of meet the best thing with backups and stuff. We see it becoming modular. Not everybody can afford a brand new life support system for every single spacecraft that goes. Going towards like the aircraft industry, that there's new generations of engines, new generations of avionics, but the actual technology that goes into the next generation of aircraft is a derivative. So we see derivatives going on after it gets established. Common interface is an interesting thing. The Apollo-Soyuz program, one of its objectives was to develop a common interface between the American and the Soviet spacecraft. So if there was a need for a rescue mission, we would have the capability to actually dock them up, because they operated at different pressures and everything else. It was very rudimentary, definitely much more politics than it was engineering, so to speak. But there is a need for that. Do we establish? Do we make a standard around 3,000 psi storage of oxygen, 5,000 psi storage of oxygen, 8,000 psi? Are the transfer valves the same? It's always amusing to me looking at sci-fi things that people run into, even an alien spacecraft, and somehow they can plug their hose directly into the alien spacecraft hose. That doesn't happen in real life without thought on it. There's a lot of that has to happen, and it's not quite there yet. It will be, though. I would say in the next 30 years, that's one of the things we're going to evolve.
I see. Okay, well, awesome. So with this, we were getting close to the end of our episode, Grant, and obviously we had a great discussion. And if you have any final notes or some message that you would like to share with the audience, I think now is a good time.
Well, I would say, staying on the technical side of it, one of the things I often get asked is, why don't we just go on to Mars? And it's because we're not ready. We don't have a life support system that can take us to Mars and back. Nothing happens with the snap of the fingers. Nothing happens. It takes work. It takes steady work. And going back to the theme of what makes a company successful, staying focused on one thing and becoming very good at your vision of what your vision is, but keeping your vision in place and not becoming a conglomerate of visions is really, really important, not only for business, but for life in general. there's so much opportunity out there now, so much, things, distractions too, with the internet and these things we carry around that have so much crap on them, as well as some useful information.
Yeah.
Staying focused is the thing that really determines success. And so just for a general audience thing, no matter what your dreams are, stay focused and try not to be distracted too much.
Wonderful. Okay, so thank you again, Grant, and I really enjoyed this conversation. And for the audience, you were joined by Grant Andreson. You were listening to his insights, and this is Nicholas, your host, and I'll see you on the next episode.